Okay, so we're going to build on that part one bending stuff by, in part two, we're going to do some tension stuff. So we're going to look at how to tension, let's say, membranes and inflate those membranes into dome-like forms. Um, and also, if we've got a little time in the end, build a very basic tent structure. So have some interaction between elements that are in compression and elements that are in tension. Okay, so I'm just going to get started. This time I'm going to model a mesh plane in order to get rolling on this. So we're going to go to mesh in Rhino, mesh primitives, and plane. And then before you click around, go to your X count up top, make that 15, and Y count also 15. I'm just going to add a little resolution to this. And then I'm going to hold shift. I'm going to put a corner somewhere, and then I'm going to hold shift. And I'm going to draw this out to about that size. This is a arbitrary size. I just want to keep it within this, within our XY plane here, within some reason. All right, so let's drop that mesh into Grasshopper. So we'll go over to parameters, grab that mesh parameter, set it on in, and then we can hide that mesh. In Rhino, don't need to see that right now. And as before, we'll head over to Kangaroo 2. We're going to grab the solver. I'm going to grab the regular solver for this one. You're welcome to experiment with Bouncy if you like. And just keep that over to the side because we're going to put some stuff in. All right, I'm going to set an anchor point to all 4 of the corners. So we were familiar with that. So we go over to mesh in Kangaroo. We go over to, where is it? Yep, mesh, fold, corner points, mesh corners. And there's our, and then we're going to set those to be anchors. So back in Kangaroo, goals point, anchor. All right. And we're going to just drop those right into our goals. And before we get too far, we're going to also do that thing that we do with the button and the Boolean. Okay. And we're going to turn both of those off. And I like to keep these together, do something like that, so that I can always find them later. Okay. The next thing I'm going to do before I forget is to grab the show, the light bulb component, and I'm going to pop that into my solver as well because I'd like that to come out from all of this. And then we can disable the preview of our original mesh because now we have an overlap, and that's not necessary. All right. And now for this simple, for this first example, what I'm going to do is add a tension to all of these lines on the inside of the mesh here. I'm going to treat them as if they are trying to stretch between these anchor points. And once again, what I like to do is I like to show those anchor points with dots like we did last time. I think it's helpful to always know where our anchors are. All right, so let's go back to Kangaroo. Goals line, grab that line / spring component, and we have to extract our mesh edges. Before we used Weaverbird and we use the mesh edges. This time I'm going to do something slightly different. I'm going to go to mesh, and in the analysis tab up top you're going to see mesh edges. Okay, grab that, pop that in. Okay, and let's look at what that is. The output of that this is the edges with valence 1 out of the E1 output. That means those are all the edges that only have one neighbor, and these are going to be out here. So that's all of my outer edges. So I'm going to show you that by selecting them like this. You can see that turn green. And then these are all my inner edges. So it's separated the outer versus the inner, and that's going to be cool. They'll give us a little bit more control a little bit later. So I'm going to copy and paste this Kangaroo line goal. Move that out of the way. And I'm going to put these outer ones in here and the inner ones here. And I'm going to assign different length values to these. All right, so we haven't experimented with this just yet. We can leave the strength alone at 10 for now, but the length we've been leaving empty because we've been simulating bending, and you don't want the length of the rod or the bending element, the wooden piece, whatever it is, you don't want that to change its length. That wouldn't be very realistic. But in fabric, for example, you would want to change, or in an inflation, let's say a balloon, you would want these lines to change their length as if they're elastic, like rubber bands, or like how fabric stretches. And if we put in a length of 0, that's going to add maximum tension relative to this strength. If we put in a factor of the length between 0 and 1 of this original length, you can modulate that strength or that tension. So let's go to math, grab the multiplier, and then let's go to curve length, okay? And out of E1, let's measure the length and then multiply that length. I'm going to give myself a little more breathing room here, sorry. Okay. And then we're going to multiply that length by a slider between 0 and 1. So a multiplication of 1 equals the exact length of what it is now. A multiplication of 0, of course, is 0. So that's how we're able to go from one to the other. And for now, I'm going to put it in as 1. You can copy and paste those three components, drop in the 2 as the input instead, and put that in down below like this. Okay? Very nice. All right, this will be clear in just a second. So let's drop these into our goals. And let's see what we get. Let's turn that on. And let's drop these values. Okay, hang on. Oh. Yeah. Yep, so go ahead and take that second one and drop that down. And you can see that it's trying to kind of, it's giving you the effect of stretching, right? In kind of the opposite direction. In reality, you've got a piece of material sitting on the desk or something like this, and you can take the four corners and kind of stretch them outward, right? We can do that in Kangaroo, kind of like what we did in the last example with bending. We can move these points, instead of inward, we can move them outward. That would also work, and it would give you probably a pretty similar effect. Also, I could turn off those mesh edges. They're getting a little distracting. The other way to do it is to add tension to those lines so that they start to look for a shorter length of themselves, which is adding a lot of tension to the system. The other thing we can also do is add strength to the outer edges in order to kind of balance out that form as best we can. So now these are the stronger ones, the outer edges, and these are slightly weaker. And because of that, we're able to kind of fine-tune, if you will, the elasticity of the object. Okay, so that's just basic example for counterforces between an anchor and tensile forces, 2 sets of those. So the outer ones have their own force, the inner ones have a different force, and the combination of those forces together produce the result. All right, let's take this one step further in the next example, which is to add a unary force in the opposite direction of gravity to kind of inflate this into a dome-like form. And this is a pretty common process for finding compression-only shells, for example. So shells that are made of masonry or concrete have oftentimes been created using form-finding physical models. So if you hang, let's say, a sheet of material and you add weight to that sheet of material between 2 points, it'll sag. And if you flip that form upside down, you get a form in perfect compression because the form that was sagging was in perfect tension. This is the basic concept of catenary structures. Okay. So let's add the unary force to this. Let's go back to Kangaroo. And find the unary force, or load as it's called now. So go to goals point up at the top and find the orange dot with the arrow, the load component. And now we have to input points into this load to apply this load to something on the mesh. And to do that, we can go to Weaver Bird. There's a couple ways to do this. You can go to Weaver Bird, find your mesh vertices like this, and that will work. So let's go ahead with that option. Another way to do that is to, if you wanted to distinguish between inner and outer points, you can also use the naked vertices component here. But in this case, we don't want to do that. We just want to keep it simple. And now our force vector is upward in the z direction, but we're going to want to give that an amplitude. We're going to want to give that a power, if you will. So I'm going to just double click in here, hit z, add that z there, and that allows me to put a number here. So I'm going to just grab a slider. You know what? I'll grab the traditional slider from our regular place. Keep that at 0, and then go ahead and drop that into our goals. And now if we add a little bit of force here, you can see now that it started to inflate that mesh, if you will, or add force to that mesh as if it were acting against, let's say, a force of gravity, if it were upside down, or a force that were coming from underneath and up. So we're adding pressure, if you will, to each one of those points in order to kind of equalize this shape and find its outcome. And that is, again, a result of not only this load, but also the strength of the counterforces, which is the material itself. I can affect this, so I can turn that up quite a bit, and you can see that I'm now getting to the point where it starts to become a bit extreme. But if I go back and add strength to my outer edges, and then add a little strength to my inner edges, I can also find different results. So if I drop this down a bit, allow that to really kind of blow out and weaken these a bit, I can also get a form that appears maybe a bit more balanced. So in this case, what we're doing is, again, adding arbitrary values to these geometric components that are in some way simulating or mimicking the way material may react. Now, these are abstract values. If we knew a little bit more about our material, there are ways to determine what these values need to be to get this object here to act as though it's the material does in reality. But that's a bit beyond the scope of the class, unless we have some time toward the end. In the meantime, I think it's just important to understand how form finding works, and that it doesn't necessarily mean that this structure is 100% compression only, but it is the first step in getting you there. And you can go ahead and play with that, with these 3 parameters in order to affect change. The other thing that we can do to add a little bit more flavor to this, or add a little bit more understanding to it, is add anchor points. One thing I haven't yet described in this intro is the nature of how to add an anchor and what affects this mesh. Basically anything, any point that exists at the same exact x, y, and z coordinate, at least at the beginning of the simulation. So let's go back and drop that down. If I have a point here, and it coexists at the same x, y, and z coordinate there, and that point is set as an anchor, it will interact with that mesh. If I draw a point, for example, somewhere else, it will miss, and it won't act as anything. So even if I, just really quickly here, if I set this point, and I add that point to my anchors, where are my anchors? There they are. So if I add this to my anchors, and rerun the simulation, nothing will happen. That point will remain exactly where it is. But if I'm going to just bake these points out into Rhino, and you can go ahead and do this if you like. I'm going to turn that off just for a minute. So if I take one of these points, and let's just pick, I don't know, that one there, for example, and maybe let's just pick 2 at the edge, maybe something here, and then another one over here, for example. And let's set these in. And now I can click that back on again. If I go ahead and run the simulation now, you can see that those points are now acting as anchors because they've interacted with the mesh by sharing that coordinate. And you can also see that as I add anchors, I change the form. So I'm going to go ahead and hide all this for now, just so that we don't distract our view, and take a look. And this is a little bit of a wonky form, but it is a form. One thing that you'll also see, and let's go ahead and show those points again, and if I select that point that we set as an anchor, I should be able to move that. Oh, I break it. I see. It looks like it won't. Ah, that's right, because of the translation. Yeah. In older versions of Kangaroo, that may have been possible. In this version, if you're going to move parts back and forth, there is a process in order to get that target updated. Not a big deal. I just wanted to show you the relationship between anchors and form. And here you can see that once again. Let me see, though, if I internalize this. See if that works. Nope, that still breaks it. Okay. No big deal. I can cover that in a future tutorial. Anyhow, that's how you might change your form once again if you wanted to control it a little bit more, or if you have something else in mind in terms of the final outcome. I'm also going to, just to show you one more thing, I'm going to grab something, let's say in the center, give you an idea here for, yeah, let's grab these 4, set those points, see what this does. Just to do a little experimentation here. Set those points in as anchors. Go ahead and hide all that stuff. Turn this back on. Yeah, so now what we've done is we've created not a dome, but we've created a kind of a column, if you will, toward the center of the space. And this is not a great way to do that because you're putting a lot of awkward tension on the mesh in this area because this is a square. So there are cleaner ways to do something like this. So if anyone's interested in funnel-like forms like this, let me know and I'll cover another example of it. But this just gives you an idea for how you might start that process. Okay? All right, so we're going to move forward with another example. Okay, we're going to start a new file. You can save this as something for your own record. I'm going to start a new one, and I'm going to head to Rhino, and I'm going to go to solid, box, corner to corner in height. And I'm going to hold shift and create a tube-like box about something like that. All right. And then I'm going to grab this, and with my gumball here, turn down below, I'm going to hold Alt, I'm going to make a copy, and rotate at the same time. And I'm going to give it a little bit of a diagonal, something like that, maybe. All right. And then I'm going to Boolean these together. So I'm going to do a Boolean union. Okay. And that gets us pretty close to what we need. Now on Rhino 6 seems to be producing this consistent surface all the way across. If you're using Rhino 5, that may not be the case. So if you're seeing a line here and here, you're probably okay. And just go ahead and raise your hand if you have a question there. But if you're seeing what I'm seeing, what we need to do is explode this. And we're going to have to draw a line from those points like this, between those points like that. And then split that surface, that outer face, with those 2 lines. Because this has to be a separate face in order for the next step to work properly. And you have to do that on both sides. Okay, so go ahead and follow along there. All right. Cool. And then I'm going to just select those curves by typing in select curve. Delete them. We don't want any curves in there. And the other thing I'm going to delete are these top, bottom, and then side faces. We don't want those either. We want to keep this as an open hollow object. And then I'm going to join all that back together into a B-rep. All right? Any questions on that, just let us know. I'm going to then set that B-rep into Grasshopper, and then hide it in Rhino. Okay, and then I'm going to go to Mesh, turn that into a simple mesh object, like this. And then we're going to go over to Kangaroo and refine that into a tighter mesh. Yeah. So let's plug that in like so. Turn off that original one there. Make sure we're still good here. Yep. And we can change our level to, let's try something like 3. So we're going to plug a panel and 3 into there. Okay, that's quite a bit. Let's turn that to 2. There we go. That might work pretty nicely for us. Yeah, so a level of 2 subdivided that mesh pretty clean. And we can keep going, but this is going to be a little faster. We can always play with that parameter a little bit later on. All right. Okay, the next thing we're going to do is we're going to head over to Kangaroo again. And let's try this out. Let's head over to Mesh, Naked Vertices. And it's going to show you all the points along the mesh. I'm going to turn off the preview for that because I only want to see the naked ones, the ones around the edges, as you can see there. Yeah, that's nice. And I'm going to set these as anchors. Okay, so we'll go back to Kangaroo, goals point, as before, anchor, and off we go. So go ahead and set up your Kangaroo stuff as we've been. And in this case, I'm going to use the Bouncy Solver. I think that's better for this example, so we can see things slow down a little bit. I'm going to set those in, and I'm going to once again grab my Boolean toggle on my button so I can do my resets. Okay, turn that off. All right. Okay, now let's set tension to that mesh once again like we did before. So go ahead to Kangaroo, grab that line component, the length, and we know we need to find those edges, so we can go to Weaverbird, extract, mesh edges, plug our mesh. Oh, we have to use the refined mesh, not the original. This is now our simulation mesh. Okay, and we go ahead and plug those line edges into the line component. And now in terms of our length, here we're going to do the same thing. We're going to go over to Math. We're going to multiply that, and then we're going to grab, we're going to multiply the curve length. So we got to go to Curve, grab that length component, and multiply that by a factor between 1 and 0. Like this. And we'll go ahead and turn that to 1 for now, and then plug that into my length component there. Okay, so it's kind of a repeat of what we did in the last example. And then I'm going to drop that in as a goal. The other thing that I will do is turn off some previews, get used to that, and we can go ahead and go to Kangaroo again and use that light bulb, the show component, to show our mesh, like so. Very nice. Let's see, what else can I do here? The other thing we can do, if you want to turn these points off, we could turn this solver off, and then, so here's the vertices coming out, and here's the rest. So we're going to end up with a mesh at some point, and we're also going to have a bunch of lines coming out. That's all we really want to be looking at. So we can go to Parameters, Primitive, Data, and just drop that in like that. That way we're seeing our anchors, and we're seeing our mesh only, without all the rest of the points, which is, I think, better. All right, let's turn this on, turn that to true, and then add some counterforce. And now what's happening is it's acting more like now an elastic membrane between those anchor points, as if these are framed, kind of sewn in or something, and you were to stretch that material in between those anchor points. And now this is a little bit low res, maybe a little chunky looking. So what we can do is go back to refine, add some levels, and now watch what happens here. It's going to look a little weird. And that's because we've changed the topology. We've actually added more mesh faces, which means we always have to do a reset. Anytime we add something like either a different mesh or we make a change to the mesh, we've got to reset that simulation. And when we reset, we can see now that we're arriving at much smoother curvature here with the higher resolution mesh. I can drop that down to 0. And you've created a kind of relaxed mesh using tension in the system against that which is holding it back, which are the anchors. And while we're in this example, I want to show you one more thing that I think is kind of cool before we move into a tent example. I'm going to go to my top view. I'm going to draw a circle, say something like this. And then I'm going to move that circle as best I can to the kind of center. This doesn't have to be too perfect for this example, but it should be kind of close. So something like that. And then I'm going to go back to my perspective view here and pull that circle up and over the top a little bit of that set of points there. Okay? And then I'm going to go over here into these, grab these, I'm going to right click on those and bake them into Rhino. And this is just a faster way of doing the next thing that I'd like to do. I can also find these points in Grasshopper, but for the sake of time, I'm just going to do it this way. Bake them in, and then we can bring them back, bring the ones we want back. And the ones we want are just the top ones. So I'm just going to select those top ones there, set those into that point parameter, not the anchor parameter, okay, into a new point parameter that I drew here. All right. And then I'm going to go to Kangaroo, and I'm going to go to the Goals On tab and grab this one called On Curve. And then I'm going to bring this curve into GH like we do. That's going to be the curve input. The points that we're relating to that is this. And then I'm going to grab a strength, set that to 10 for now. And then I'm going to add this to my goals. Okay, looks like the strength may not be, oh, right. That's, the reason why it's not reacting is because those points are also simultaneously set to anchors. So in order to do this properly, let's turn this off for a minute. Let's reset this set of points to the other sets of, to this set, that set, and this set. Okay, so those three sets will be our anchors, leaving those out. In order to do that, we'll need a new point parameter, set those, and then replace the anchors coming out of that component with the ones we just set from Rhino. This is, again, breaks the parametric, let's say, workflow, but that's all right usually with simulation. A lot of times you're just kind of setting stuff back and forth between Grasshopper and Rhino. So we can go ahead and run that. And now what we're doing is seeing that this curve itself here has a kind of a gravitational pull. These top points are pulling themselves to the closest point on that curve. And it also is affecting the geometry up at the top here. Now if we increase the strength, this force is now being counteracting it's counteracting the forces in the mesh itself. So the higher this is, the more likely it is to stretch far enough to actually reach that curve up top. Depending on how important that is to you. Maybe it's not all that important. If it's just form finding, and you just want it to turn this square set of points into a circle, you've done your job. If you really want to make sure that those things are touching, you got to increase that strength quite a bit and test whether or not they've actually hit. But you can also do this in order to set different shapes. So even though it started with a square, you've ended up with this kind of horn-like form, this trumpet-like form, just by adding another goal to the system. And this is a more effective way of arriving at these kind of forms than trying to model circles, because you're going to let the simulation do the work and model simpler things like boxes. Boxes are simple to make. Curves like this are not. And let's see if I'm going to show that curve one more time. I'm going to hide this. And I'm going to see if this works too. I'm going to move that around a little bit. Yeah. So I can interact with this Rhino object and make some changes. Now this has a limit. The more I make a change like that, the more it may break, because it's going to look for the closest point, remember. It doesn't know any better. And now I've gone ahead and broken it. And it's going to be hard to get that back without resetting. But if I reset I can make some changes. Very nice. Okay. Great. You can save this one, and we'll move into another one. Okay, I'm going to start a new file. Go to new. You can go ahead and hide all that. Later on down the line, you can save this Rhino file as well. Okay, so we're going to have to do a little setup in Rhino. Going to once again draw, go to the top view for this one. I'm going to draw a mesh plane, and this time I'm going to make my X count 10 and Y count 10. Just drop it a little bit, and go ahead and drag that out with Shift, holding Shift so that it's symmetrical, and draw that mesh. And before we move it, I want to draw a center point. I just want to reference that center point. So I think that center point is going to be, let's see, 1, 2, 3, 1, 2, 3, 4, 5. It's going to be along that line. So 1, 2, 3, 4, 5. I think that center point is going to be right there. Okay, and you could probably eyeball that, no problem. The other thing I'm going to do is draw some points at those vertices, like that. Okay, I'm going to go to my perspective view. I'm going to move this mesh up a little bit. Maybe that's a little too, something like that maybe. And I'm then going to scale. I'm going to select, make sure I'm in good, yeah, okay. I'm going to select this. I'm going to select these 4 points and scale them from the center point inward a little bit, say to about here. Oops. Before you do that, run that command again, the scale command, and then make sure you click copy up at the top so that you make a copy. And there's your base point, and now you made a copy of those points. And then do it again, and then bring them out farther. So you've made one set that's in, and then you're going to make another set that's out, like this. Let's see, about maybe that far. So let's look at that in the top view so you can get a sense. So if you can see my top view, I've got those inner points over here, and then the outer points out there. Okay. You can go ahead and raise your hand if you have a question about that. The next thing I'm going to do is start connecting some dots a little bit here. So I'm going to just draw a line between that vertex. By the way, if you can't select that vertex, it's down below in the OSNAP options. That's not an endpoint, that's a vertex because it's a mesh. And then snap that to the inner point. And then do that for all 4 corners. Like this. So that it looks like that. And then we'll also draw our cable. So these are going to be our columns, and then we'll also draw cable elements like that. These are going to be the things that are holding those columns back so that they don't topple over when we force the tension into the mesh. Okay, so we've created a basic low-res tent structure that has yet to be simulated into a membrane shape. And now we're going to set these elements into Kangaroo and simulate them together. So what we're going to see now is an interaction between the membrane itself, the cable elements, and the compression elements, which are the columns. So the first thing we got to do is set our geometry. So let's grab a point parameter and bring in our anchor points. We can set multiple points here. And you can grab the anchors for both the cables and for the columns. Okay, the anchor points have been set. And now we need to bring in the curves. So let's bring in our columns separately, right? So that's, and we're going to label that column so that we know. And then we're going to bring in another set of curves here, and these are going to be our cables. like that. I'm going to label that cables. All right, and then we can just bring in our mesh also, so we're going to need that as well, of course. Okay, cool. All right, and I'm going to take all that and go ahead and hide it all. I don't need to see it now because it's in Grasshopper. Okay, and I think you probably see what's coming next. We're going to start setting up our kangaroo situation here. First thing I'm going to do is head over to kangaroo, grab that Bouncy Solver, put it over there, get it set up with a button and a toggle. Alrighty. Good. Move that over. All right, and now we're going to grab our anchors. So go ahead, kangaroo, goals point, anchor. Points are anchors. Go ahead and drop those in. Okay, columns. So the columns, we are going to add the same kind of goal that we did with tension. So we're going to go with goals, line, length. And now the length is going to remain the same. And our strength is going to be something very high. We don't ever want this to change. So I'm going to put in 3,000. All right. And just to demonstrate in the file that we're not changing the length, I'm going to do this as well. I'm going to measure that length and then force that into there so that later on when you open this, you know the difference between columns and cables. So that is now set as a line that cannot change its length, but is an important part of the simulation, so we need to set a goal. The cables, on the other hand, actually the cables we could also do something similar to. We don't necessarily have to change their length. We could change their length to do some form finding, but in this case I'm just going to make it so that they're a little bit weaker. Let's see how that works. So I'm going to leave this alone because we may change it later, and instead I'm going to make this strength, let's say 200. Let's see how that goes. I don't know how that's going to react just yet until I start. Okay, and then the next thing is to add the forces to this mesh, right? So we're going to go to kangaroo again. Sorry, we're going to go to Weaverbird, grab our mesh edges, and run that through the same goal. But in this case, we're going to multiply that again, that length, by a factor between 1 and 0. Because this we want to add tension to, as if it's some kind of fabric membrane. So I'm going to do that, make that 0 to start. And then the strength on this, you know, of course, is related. Because if this overpowers our structure, it may topple over. So let's add this as a component that we can change. Let's just make it 10, see how that goes. And this may topple, so let's see. Pop that in. Okay, hit reset. And let's see how it goes. See if we, okay. Looks like we got a little bit of a problem here. One of the problems is I forgot to input the cables. The cables weren't doing anything. They were just snapping away. So let's try again now that the cables are in. Okay, so we're starting to see some good stuff happening here. So I'm going to turn off my previews of things that are overlapping, all of the stuff that we put in, and only look at the simulated geometry. And I'm going to zoom in a little bit on this condition here at the corner and then add some force. So you can see that there is some interaction between the cable strength and the ability for this column to rotate and the tension that's being applied. Now if I drop the strength, let's say, of these cables down to 20, you can see I'm even getting more interaction. It's pretty nice. Now, in reality, you probably don't want that to happen, but this is a great test for us to see if our system is actually acting as a structure that's finding an equilibrium. And that's what's happening. So there's an equilibrium between all of these things. The columns are set to be able to hold their length but also rotate between that anchor and that point. The cable itself is able to stretch, and because of that, we're seeing that rotation happening in the column relative to those forces. So if I say, you know what, I don't want this thing ever to, well, let's say I want it to be stronger. The only thing that I can then do to find that movement again is to increase the strength here. And that might be way too high, so let's see. Well, no, that's okay. Yeah, and in that case, I get kind of the same effect, right? As you can see, these are just arbitrary values that you can, in fact, if I change that to 2, change that to 3, we probably will see a similar result, but a different kind of behavior. Remember, it's the forces, the numbers of the forces don't matter as much as the relationship between them, the ratios between them. So a 200 to 300 is a similar ratio to 2 and 3, for example. Okay, so that's it for introduction to Kangaroo. We've gone over bending. We've gone over how to bend a simple object, apply that same logic to a structure, and then we went over how to apply tension into this using similar elements. So applying tension to lines and points, inflating that into a compressive form, for example, like a dome, and then using elements in unison with one another, like this example, to find an equilibrium between things that are in tension, compression, and things that are acting like fabric. Okay.